All right, we are going on to quadratic functions, lesson 2, and we're going to analyze the graph. That's what we're doing today, okay? So quadratic function, just to go over what we did before in lesson 1, you can write it as f of x, a function of x, or you can write it as y, okay? Where a, b, and c are real numbers, you can't have any unreal numbers, and you must have the x squared, so a cannot equal 0. So just to go over what we did in lesson 1, this and this can both be 0. They cannot be there, but x squared must be there. And on the graph, we have this fancy word, parabola. So quadratic function has a parabola. It either has a maximum or a minimum. If it has a maximum, then the graph goes up to a maximum point and back down again. If it has a minimum point, then the graph comes down and then goes back up again. Okay? So this one's a maximum, and this one's a minimum. The vertex is this point right here on this graph, okay? That's called the vertex. And it's that maximum or minimum point. It's always going to be a maximum or minimum for y. Because x is going this way and there's infinite x's. Okay, so if we complete the following graph, you're going to take this number and you're going to put it in for all the x's here, there, and there, okay? So this is going to be y is equal to -1. Don't forget you're squaring the negative as well. Minus 6 times -1 plus 5. Okay, so that's y is equal to 1 plus 6 plus 6 plus 5. Okay, so that is, sorry about that. That is 12. Okay, if you do the same thing for 0, I'm going to just pause here. I want you to go ahead and put the other numbers in, 0, 1, 3, 5. Okay? You figure those out. So just pause me. Okay, so hopefully you got the answers. 5, 0, -4, and 0. Plot the points on the grid provided. Connect, I'm doing number 2 right now. Connect the points with a smooth curve and extend the graph. Well, that's easier said than done. All right, so I am going to start with, I kind of see it's going here in the middle because I have -3 here and a -3 here. So I'm going to actually start with that. 3 and -4. 1, 2, 3, and 1, 2, 3, 4. The next ones from that are 2 and 4 and -3. So 1, 2, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3. Okay. So I have 3, -4, 4, -3, 2, -3. Now I'm going to just pop right up to here. 7 and -1, they both have 12. So I'm going to go -1 and all the way up to 12 here. And what was the other one? 7 and 12. 5, 6, 7. I'm going to follow that up here to 12. Now, for the smooth part, let's try it. Let's try it. Easier said than done. Don't forget to put those arrows on the end, okay? Telling me that it keeps going on forever, okay? All right. The graph for, am I on number 4? Sorry. Number 3, draw a vertical line representing the axis of symmetry. So that's where it kind of, you can see, oh, that's a terrible line. I do apologize. It kind of flips over that line. So this is the axis of symmetry. And that's always going to go through your minimum or your maximum point right down there, okay? All right, number 4, fill in the blanks or circle the correct alternative below. Okay. The graph of a quadratic function, y equals x squared minus 6x plus 5, is a parabola, like all parabola. The vertex is this lowest point right down here, so that is 3 and negative 4. The parabola opens up, which means it's going to have a minimum point. Nothing goes below that, okay? The minimum value is, so the lowest point here, y is equal to negative 4. The x-intercepts, those are the 2 points where y is equal to 0. So I might come back up here. Here's where y equals 0. That's where it crosses over x. Are 1 and 5. The y-intercept when x is equal to 0 is 5. The equation of the axis of symmetry is, on this line, when I'm looking at this line, x is always equal to 3. If I go here, x is equal to 3. If I go here, whoopsie daisies, pardon me. If I go here, x is equal to 3. If I go here, x is equal to 3. Okay? So the line is x is equal to 3. The domain, x can be all real numbers. There's nothing x cannot be. So x is all real numbers. The range, well, y cannot be below this line. So I got to do those lovely brackets. Y such that y is greater than or equal to negative 4. And it is also all real numbers. Okay. How can the equation of the axis of symmetry of the graph be determined from the x-intercepts of the graph? Oh, interesting. Okay, so if we know there's 2 points here, we've got these 2 points, 5 and 1. This is where it crosses over the x-axis. So this should actually be here, sorry. 5 and 1. This line is directly 2 away from both of those. So what I can do is 5 minus 1 is going to give me 4. And then I'm just going to divide that by 2, which equals to 2. So from this point, it's 2 away from this point, and it's 2 away from this point. So I would say 1 plus 2 equals 3. I could also just say from this point, no, we're not going to do that. Okay? All right. On your graphing calculator, you can find your maximum and minimum, but what you have to do is tell the calculator points to the left of what you think the maximum is and points to the right. And then it finds in between these 2 points the maximum or the minimum. Okay? Just follow those steps. 1, 2, 3, 4, 5, 6, 7. Okay? And the same for a minimum point. You just use minimum instead of maximum. Okay? All right. Do not go beyond this point without trying this on your calculator. Stop now and do it. Okay. So, if I was looking at this, I'm going to say that I want to get up to 15. At some point. Okay. So when you look at your window setting on your calculator, I would make your X maybe go from -5 to +10, and every line make it a value of 1. Okay. So on your graph, you're going to go from -5 up to 10, and each of these little lines is going to be equal to 1. Okay. I don't know how many I have in there, but this would be 4, 3, 2, 1. This would be 0 then, right? On your Y graph, let's try it with -10 to +10. That's a lot of little lines. You won't see them if you're trying to get into 20. So let's make every line worth 2. Okay. So every line will then be worth 2 going up. So if this is 0 here, 0 here, this would be 2, 4, 6, and so on. Okay. Determine the coordinates of the vertex. So here you're going to put in put the 2x squared minus 13x plus 15 into your calculator. And you're going to do exactly what they taught you to do up above. Okay. Now, if we have the vertex, how can I find the equation of the axis?
Lots of marking still?
So hopefully you found here, this is 3.25, and this is negative 6.125. Okay. So on your graph, That means that when x is 3.25, y is negative 6.125. Sorry about that. Let's try that again. When x is 3.25, y is negative 6.125, and this is going to open up somehow like that. Okay. So that means that this is your axis here. The value of your x is your axis. So that's going to be x is equal to 3.25. Okay. All right. So on your calculator, you should be able to find your x and your y intercepts. Your x-intercepts should be 3 halves, or 1.5 and 5. And your y-intercept should be 15. Okay, so now if we're using this, your x and your y-intercept, we're going to now use the x-intercepts to find that axis. Okay, so 1.5 plus 5, I'm going to divide that by 2, is then going to give me 13 quarters, or 3.25. So that means that x is equal to 3.25 is that line in between those 2 points. This is your x-intercepts, and then there's a line right between them. And that's what this line is. Okay, so the minimum, you're going to do that on your calculator, right? Y is equal to negative 49 over 8. Domain. X is all real numbers. Range y such that y, I'm not going to use this, greater than or equal to negative 49 over 8. We know it's greater than because it's opening up. And y has to be real. Okay? Okay. The line x is equal to 2 is an axis of symmetry of the graph y equals 4x squared minus 16x minus 9. So on a graph, 1, 2, this would be an axis of symmetry. So we know the vertex is on there. Without using a calculator, algebraically determine the coordinates of the vertex of the graph. So we know that the vertex has to be on that line. So when x is equal to 2, somewhere on this line is going to mean that's the point, the vertex point. So I'm simply just going to put in 2 instead of x. And I think we're going to get y. Sorry, this is y equals. I think we're going to get y equaling negative 25. So the vertex point is y is equal to negative 25, my bad. And x is equal to 2. So the vertex is 2, negative 25. Okay? Now you can go on and do numbers 1 to 5. Okay, here we go. Part 2. Now that you've done numbers 1 through 5 in your book. So let's look at what all of these things mean, A, B, and C, inside of this graph. Okay, and what they do to our graph. So if this is what we're looking at, y is equal to ax squared. And we put it into these terms. There's no b and there's no c here. So if I make b equal to 0, and the c is also equal to 0, then this is true. C is 0, b is 0. Okay? So investigate what happens to the graph of the function when the value of a is changed. Use both positive and negative values for the parameter a. Write down your observations. So what they want you to do is in your calculator, make a different things. So if you see a is equal to, well, start with ax squared. So a is equal to 1. And then maybe try y is equal to 10x squared. And then try maybe y is equal to negative 10x squared. And see what you notice. So I want you to pause me here and actually go and do this. It's the playing around that's going to help you understand. So the first thing we should notice, if a is positive, then the graph opens up. If a is negative, then it opens down. Another thing you hopefully noticed is if a, let's say you tried a is equal to 2x squared, as a changes, it compresses or stretches. Did I spell that right? So it might get skinnier, or it might get wider. And which one did you notice makes it go wider, and which one do you notice makes it go skinnier? Okay. Now, for y, y is equal to x squared plus bx. We're going to try to figure out what a and b are first. So y is equal to ax squared plus bx plus c. So here, this is equal to 0. This is the same. And your a here, to keep this, is going to have to be equal to 1. Okay. Because 1 times x squared is x squared. Okay, so what happens if we change b? So now go ahead and put some things into your calculator, like y equals x squared plus 2b, y equals x squared minus 2b, y equals x squared plus 10b, maybe another one in there as well. Okay. So go ahead and do that. Note what you see changing. So something you should notice is when x is equal to 0, y is equal to 0. So you always have on your graph a point that this is going through. It always goes through that middle section, okay? And then the other one, the other part of this is when another intercept is the word I'm looking for, is when it's equal to negative b. That's another intercept for y. Okay. Okay, investigation number 3. So y is equal to x squared plus c. I put this into ax squared plus bx plus c. Plus c is here. Plus bx has disappeared. So that means that we have to make b equal to 0. And then again, a is going to be equal to 1. 1 times x squared is x squared. All right, so the same thing here. I want you to put in to your calculator y equals x squared, try plus 10, y equals x squared minus 10, y equals x squared plus 2. Okay. Pause me and have a look and see if you can figure out what's going on there. Okay, so hopefully what you notice is the parabola has a y-intercept at C. Okay? And the reason for that is if you think about this, if x is equal to 0, which is when there's a y-intercept, y is going to be equal to whatever this is. So it might have a point here at 2. Or if it's this one, and x is equal to 0, then y is equal to negative 10. So it has to go through that point. So that has to be the y-intercept. Okay, carry on. The shape of a graph is called a parabola. The graph is symmetrical about a vertical line called the, so that's this line that goes right down through the middle of it. What is that called? The axis of symmetry. If a is greater than 0, so that's y is equal to ax squared. If this is a positive number or greater than 0, then the parabola opens up. And if this is a negative number, if it's less than 0, then it opens down. Now, if the parabola opens up, the vertex is a maximum or minimum? Minimum. Minimum. And if it opens down, then the vertex is a maximum. So another way you can say that is the y-coordinate of the vertex is the minimum value. Okay, you might see this. What is the minimum value of 3x squared plus 2x plus 3? And so you're looking for that minimum point. And so the same with this one. This would be a maximum value. Okay. The domain of the graph is x is all real numbers. And we notice that, just remember here, the c here is your y-intercept. So you should notice that if y is greater than 0, then the graph has a positive y-intercept. And if it's less than 0, then it has a negative one. Okay? And then they've drawn you these lovely little things here. Here, a is greater than 0, so it opens up, like here. A is less than 0, then it opens down. The vertex is your minimum point. The vertex is your maximum point. And your axis of symmetry goes through your vertex. Oh, sorry. All right. Onwards and upwards. Complete assignment questions 6 through 15.